Good afternoon. My name is Bob Anderson. Today I'm going to be talking about the RCA RR-359 field trial set. I'll talk about a few topics. One, what the heck is a field trial set and what is a field trial all about? Two, what were some of the technological challenges they faced and what were the solutions they came up with? And finally, how that evolved into what we would recognize as a television. So what I have next to me over here is the upper chassis from an RR-359, which is a field trial set that was produced around 1936, 1937. But it's not the first set, it's not the first field trial set. They go back to the early 30s. What the field trial sets was, well, right there in the name. They're trying a TV out in the field. You may hear things like, oh, this was the first flat screen TV, this was the first color TV. Well, these predate that. These are the first TVs. This is the dawn of television. RCA spent a lot of R&D time and effort into creating everything. It's not just a matter of making a TV that somebody takes home, plugs and turns on. You need a camera, you need a studio, you need a mixing console, you need remote field units for live sporting events, and on and on. So this was just one piece of a vast effort centered around the New York area where they had an experimental transmitter. Well, they wanted to see how would this work in somebody's home. So they produced these sets to have in people's homes scattered around the area around the transmitter to try out in the field. The early sets, the really early ones from say 32, 33, only a handful were made. Very few, if any, still exist of some of those early ones. This one is significant for a few reasons. One, it built on all the technology that came before it and produced something that for the first time was recognizable as a television. That you could turn on, you could tune in multiple channels, had a decent sized screen. But also they made a significant amount of them. The production numbers, it's a little hard to get exact quantities. The earliest ones, like what this came out of, were only 9-inch, and they were still experimenting with phosphor composition. So I believe if we can get this working again, it has sort of a sickly green sort of phosphor color. Later ones did finally develop P4, what we would recognize as the black and white TV, but I think this one's actually greenish. But this was the first set that they actually did public demonstrations with. They invited the press to. If you go back and look at old magazines of the period, there were a significant number of articles where reporters were invited to see TV for the first time, where they did well, they fired up everything. They did a live studio presentation, and they had a dozen TVs set up in a large room like this with an audience, and they were seeing TV for the first time. They were at the World's Fair. They were at the San Francisco Exposition. So this is the first time they took it out of the lab and not only did more tests with it, but they showed it off to people. And there were a lot of articles in 36, 37, TV is here, TV is ready, TV is coming. Reality was it took a couple more years, and I'm going to talk a little bit about why that was. So that's what the field trial sets were. A handful of sets sent to select people. I would imagine they were RCA employees, technicians. They brought them home. And they took notes. They recorded problems, and they would send these back to the lab, and they would tinker with them. These were designed to come apart easily. This upper chassis has 2 pivot points, one on either side. It tips out easily. Some of these are modules, horizontal and vertical oscillator on units that come out. That was significant because while they tinkered with these, they improved the screen resolution. Originally 343 lines, then 441, and 525 eventually. So the frequencies changed, the bandwidth changed, which is what some of these modules are about. So they were meant to be modified, tinkered with, and they all were. This is one of the most pristine ones I've seen, but even so, there were changes made. We think this module was added for FM sound. Originally it was AM sound, but while tinkering with these, they started experimenting with FM sound, so they added an FM discriminator, and we think that's what that is. So I mentioned there were technological challenges. Well, one of them, the most significant one that led to the very odd construction of this, is frequency response. This was made with tubes that were commonly used in the 30s, like kind of Coke bottle, ST type, I guess they call these, where you've got a grid cap on top and pins come out the bottom and they're big. Well, if you know anything about TV IF, typically you'd have 2, 3, 4 stages of IF, where you would couple the grid from one stage to the plate of the next, grid to plate, to have the tubes stacked up in a row. But you're also probably more used to seeing tubes like this, like a 6J6, a 6AU6, a 6CB6, little 7-pin miniature tubes, where the plate and the grid are coming out of little pins on the bottom. Everything's very small, very close together. Quite different from something like this. Why does it matter? Distance matters when you're working with high frequencies. We're talking tens of megahertz. These were radio tubes meant for tens or hundreds of kilohertz, not tens or hundreds of megahertz. So when you're talking about the distance between the plate, which is a pin down here, to the grid that's way up here, stray inductance, stray capacitance, pick up noise, not so great. So what they ended up doing to couple the stages, I'm not sure, but I think these are the 3 IF stages for the video, and see how they're staggered 1, 2, 3 next to each other. Grid, plate, plate to grid of this tube, plate from the output of this tube into the grid of that, and so on. So they made these as physically close together as they could get them to couple the signals as cleanly as possible from stage to stage, which was a pretty clever way to do it. Another problem was these tubes, as I say, were not meant for high frequency operation. They did what they could using off-the-shelf tubes, 6C6, 6D6, but for some more demanding applications, they needed something a little better. So some of the tubes in this set, like this guy, the mixer tube, it's an experimental tube. It's an A305A, I believe, which I'm sure is something you've never heard of before because they were only used in these sets. But what you may have heard of is what they led to, which is a tube like this. 1851, 1852, 1853, also known as a 6AC7, I think a 6AB7. Octal tubes, metal octal tubes, grid cap on top, metal shielding. Not as small as a miniature tube, but smaller than what had been there before. And internally, smaller elements closer together, less inductance, less capacitance. And as they tinkered with these sets, some of them incorporated those tubes. So I've seen some of these sets where instead of that tube, they've got a tube like this. These experimental tubes, as you can imagine, are basically unobtainium. So it's lucky that this one is still here, and I think 2 of these others, there's an A306A somewhere down in here as well. If they're bad, you're probably not going to find one. You may have to retrofit the side, like any of you are ever going to find one of these, I should say too. Let me back up a little bit. So how many of these were made? 100, 150, 200, something in that ballpark. How many survive is a different story. As best I can tell from looking at records on the museum's website and my own asking around with collectors, there's maybe 5 or 6 in individuals' hands, and the rest are in museums, maybe 15. So there's maybe around 20 of these total that still survive. So all the information I'm giving you is gleaned from talking to other owners of these sets, looking at what photos there are of them. Very little information. There's no Sam's Photo Fact on this. There's no rider service info. These were never sold to the public. It's a miracle that any documentation survives. Luckily, it does. Another collector has a treasure trove of original schematics and photographs that make him working on these possible at all. So back to the modifications. As they learned out in the field, they took the results back and they started modifying these. So I say this one is mostly original. Another modification they made, in addition to swapping out these experimental tubes with production tubes that had better characteristics, is some of these other tubes they upgraded. Like these are 42. Number 42 tubes, typically used audio push-pull output in radios. These are the horizontal output tubes. They later switched to 807s, I've heard, and put a shield over it for a little bit of safety. They tinkered a bit with better IF tubes, video amp tubes. They swapped out some of the IF circuitry as bandwidth increased. And that's another interesting construction technique. So not only are these tubes mounted flat and hooked up in an odd way, there are these cans below. So the tube is up here. It's connected up here. What's down here? Well, these unscrew. And what's down in there, that's the IF can, or IF coil. So just like in a radio, we've got a primary, a secondary, we've got a capacitor across them, and you can tweak the tuning on these. These are your IF cans. They don't quite plug in so you can swap them out, but they do unscrew and you can disconnect them from behind. So I imagine as they increase the bandwidth, they either realigned these or they just replaced the whole thing with one that had better characteristics. Put that back on later. Now, another odd thing about the construction on this, well, what do you need for a TV? You need a screen. So originally these were made with 9-inch, but most of them were retrofitted or later production changed to 12-inch. Not sure exactly why, other than I can tell you they were rapidly developing CRTs, picture tubes, while they were tinkering with all other stuff. I said there were a lot of elements. They were working on camera tubes, all these individual tubes, and the picture tubes. But even with improvements, they were still crazy long because it's kind of a demanding application to deflect an electron beam, and you have two basic choices, electrostatic, electromagnetic. They both have trade-offs. With these sets, they went with electromagnetic, which means you have a yoke, and you need to generate a magnetic field, and you need to push that electron beam up, down, left, right, which is kind of demanding. Again, with these 42 tubes, these go to a push-pull output transformer that's on the other side of this, and that drives a deflection yoke. The best they could do was not that great. So we're used to maybe more modern tubes with like a predicted CRTs, 110-degree deflection angle. That's really hard to do. You need to whipsaw energy back and forth really fast. These didn't have flybacks. They hadn't developed those yet. It's basically like an audio amplifier. You're driving a transformer, the secondary goes to the yoke. It's like driving a voice coil on a speaker. So they had to make the picture tubes long because they had a low deflection angle. And you can see that in this set over here. The problem with that is either you have a really small screen to make it short enough that you can make a direct view, or if you want something like a 12-inch screen, they need to be long. So you end up mounting them vertically and using a mirror and lid. So the cabinet that this goes into when this is all fully assembled, the picture tube is very similar to this. It's pointing straight up with a mirror, and you watch the screen in the mirror. So we had long picture tubes to contend with. We had this strange arrangement to get the bandwidth and the frequency. And even with all this, it still wasn't that great. But it was impressive what they could squeeze out of radio tubes. One other thing they had to contend with is focusing the picture. Just like with deflection, you got electrostatic, electromagnetic. You can do electrostatic focus, you can do magnetic focus. Most TVs I work on are magnetic focus from the 40s into the 50s. This is electrostatic focus. Yeah, they had that way back in the 30s, but it needed a higher voltage, around 1200 volts. Okay, well, the picture tube runs on about 6,000 volts. So why don't we do what most sets do and put a resistor divider and put a pot on there and run a wire out of that to the focus pin on the CRT, and you vary that and you got your focus, right? They didn't do that. My best guess is because they didn't want to put a control that had 1,000+ volts on it that a user would be manipulating. Maybe they didn't trust the insulation, maybe they weren't available. For whatever reason, they decided, okay, let's keep the high voltage away from any controls from the users. Instead, what they did is they varied the voltage going to the primary of the focus transformer. So they used two separate high voltage transformers. One to make the 6,000 volts, one for the focus. And to vary the focus, instead of taking that high voltage and rectifying it and filtering it and putting a potentiometer on the output and varying that, they put a rheostat on the primary and they vary the AC voltage going into it. Downside is you need two high voltage transformers, two high voltage rectifiers, two high voltage filter circuits, etc. But that's what they did because they decided they needed to. Oh, I'll talk about one other quirky thing with this set, which is the tuner, which is this thing sitting up here. I don't know why exactly they did this. Radios have been around for a while. The guys who designed this knew how radio circuits work, but they made a really crude tuner for some reason. Variable capacitor, local oscillator tubes stuffed right into it. It's a number 76 tube again, because they were really pushing these tubes to their limits about what they could handle frequency-wise, so they wanted to keep everything as short as possible. And it can tune from around 40 to 90 megahertz roughly, which is pretty impressive for just a single tube stuck into a variable capacitor, but it doesn't work that well. What they did is they have a single coil form with 3 coils wrapped on it. The antenna input coil, the local oscillator coil, and the mixer coil. Nothing shielded, radiates the local oscillator right back out to the antenna. It's just all sitting right out here. But that's what they did. Later sets, they did have I think it was a 12 position tuner, something we'd be more used to seeing with a bit of a click. And they used, again, a more refined tube for the mixer. But they, yeah, anyways. So some very quirky, clever things to make radio tubes that were never designed to work in the tens of megahertz, How well did it work? I do not know, because I've never seen one of these sets in personal and operation, but I do own one that needs a lot of help. It's going to be a while before I get it working. This chassis came out of the set that belongs to the museum, which we may get working. We may. We're taking a look at it at this convention, and we'll see if we can get it operating. What this led to, after they took all of this out, as I said, these were never sold to the public. This is 36, 37. It took them a while, but eventually in 39, Big World's Fair, you may have heard about, they really pushed their commercial line. They finally came out with a series of sets, TRK5, TRK9, TRK12, that incorporate all they learned from this to produce a chassis like this, which is out of a TRK9, which instead of having these tubes, it has all metal tubes. Pretty much. There's one or two of the older style tubes, but almost every tube in it is a tube like this. And for this, for the high voltage supply, they did go with a single high voltage transformer and a voltage divider and a focus pot that has 1,000+ volts on it. So either they figured out a way to do it safely or whatever, but they did simplify things and go with a more sensible approach with this chassis. And these are what they sold to the public for a few years, and then unfortunately World War II broke out, and well, things were put on hold. And then right after the war, they came out with sets like that in 1946, where they took, again, all the stuff they had learned between 39 and 46, and now we got all miniature tubes and a more smaller condensed set that still had pretty impressive. Actually, I would say it had superior performance to these sets in a much smaller package, because they incorporated all the advancements made during the war. That's all I have to say right now, but I welcome you to throw any questions at me, to come up and take a look at this chassis. The rest of the set is in the early television room if you want to check it out. I'll mention one other thing about it. As I say, this is early. We're talking mid-30s. The power supply is pretty impressive looking because electrolytic capacitors were still in their infancy. So most of the filtering is done with filter chokes, very large filter chokes. Also, as I said, no flyback. So how do they make the high voltage? Brute force, like a neon sign transformer, 60 hertz in, many, many turns of wire, 60 hertz high voltage out. Yes, a Widowmaker, very lethal, 6,000 volt power supply output that uses a rectifier tube that looks something like this, which is, the filament on this is 2.5 volts at 5 amps. The very, very beefy high voltage tube. Yes, that would very likely kill you if you were to brush into that while the set was operating. So not for the faint of heart.
Hey Bob, when did they actually start commercial broadcast of TV in America? Was that late 30s?
That's a very good question. So during the field trials, I believe they were only broadcasting from the Empire State Building. When they started pushing TVs to the public in '39, there were other stations in other cities, but there couldn't have been very many. But there were more.
So what they did do, and this was a feat in itself, through AT&T long lines, they did link, and this was a feat because they were just delayed the coax. They linked New York, Philadelphia, and Schenectady. So that would go that, and that was their first like TV network. And that also included all the places everyone in the country was really experimenting with television, because Philly was doing early stuff with Farnsworth, and then separately, and then Schenectady with GE. They were trying to develop a high frequency transmitter that could broadcast television, and so they got that signal. So it was the three of them would, New York, Philly, and Schenectady, would relay signals back and forth between them. Other areas did have it too. Pittsburgh notably had it, even at their county fair, but it wasn't broadcast. It was all closed circuit, which a lot of the World's Fair was also closed circuit, and you could get a little card that say you were televised on closed circuit television. But they did have a network, and they did do broadcasts. And other places tried it too, you know, like famously KTSP out in St. Paul was another one. But RCA actually sold like kits. They like deliver them like, here, you want to play with it, you can have it. But that was the broadcasting, and they do have, there's one surviving film from the 30s where this set would have been used, where Pathé just was on set. You don't see any of the stuff off screen, but you see the acting, and you will see some famous, what will become later famous actors were on that experimental television from 30 Rock.
It was a tough sell, and when TVs came out, they cost a fortune. There was almost no programming, so it did.
The other thing was the FCC was not sold on 441 lines AM sound, so this was, none of this was commercial. It wasn't until they got involved and set the standard to 525, and that was July of 1941. So,
I had a question. In the 1939 World's Fair, did you say that the commercial model of the exhibit did or did not have that higher voltage passing through the consumer control?
It did.
They did have
The TRK series, they do have high voltage on the focus potentiometer.
Why was that? Did you say better shielding? Or?
Well, and this set does too, the 621. I think they figured out how to use porcelain, Bakelite, or whatever, and make a safe high voltage focus control.
The focus control on the TRKs is not user accessible, but it's on the back, and they use a phenolic rod.
Oh, there you go.
Oh, okay. That's how they, I see.
So I guess we could say safe maybe in quotes.
Bob, I missed the first part. The CRT, does it exist, and has it been tested, or can it be tested?
It does exist, and it is good as far as we know. This,
It's a green
yeah.
where is it in terms of, you said it's not working right now, this set?
Yeah, it's my understanding the set was working when the museum acquired it, but after taking it apart, we don't think the set was ever fully assembled and turned on here.
I saw it
Because
play.
the cable harness, oh, you saw it playing.
Yes, Nate Pendleton had it
Right.
in Charlotte,
Right.
and he had it up and running. They were feeding it with a VCR.
Oh, yeah, but was it ever working here?
Right. That was like the year before.
Right,
it got
right.
brought here.
Yeah, so we're questioning whether it was ever actually all hooked up and turned on here. So it might work fine. We don't, it has been worked on. If you look around the back, the capacitors have been restuffed. It doesn't look like anything's been done, but it has been. It has been electrically restored.
New wiring.
Boy, that chassis looks so nice, and this is all rusty.
Well, as I said, this set was restored, I think, back in the 80s or 90s, and probably kept in better condition.
That must have been a barn find or something.
Does anyone in here know where Jeff Landaro's 1935 set wound up?
He's
like
got,
a
he's got one of those.
Huh?
He's got a R359 inch.
Yeah, John, he still has it.
Okay, he told me that had experimental tubes as well.
Yep.
Yeah.
Okay.
Oh yeah, so you would ask about the picture tubes. I wanted to throw out there that, as far as I know, only one original of the 12-inch. I don't know if any, or maybe one or two of the 9 inches exist, and one of the 12s. Oh, the original experimental CRTs that were used in the 359s.
Oh, yeah.
So the one I have came with a 12AP4, which doesn't quite fit right. It works, it fits okay, but the original was bulbous and.
You mentioned the TRK5. Did they make a 5-inch?
Yeah.
Would that have been the
Those are electrostatic, though,
Yeah.
I do believe. I think it's a 5AP4.
that'd be
Anything else?
there's one of the 12-inch of that up at the AWA Museum.
Yes, there is.
Field.
Yes. I did some R&D and I tracked down every one that exists that I know of in the world. There's one in Japan. I think there's one in Germany. There's several in Canada.
Are there any still in Russia? Because I know.
I'm sure.
I
I'm
think
sure.
We just don't know about them.
Yeah, because RCA flat out sold some to the Soviet Union, and I think they made their own clones too. And on that note.
Well, in that book with the Russian set that we just brought in, there are pictures of the Moscow television studio, and you see.
Oh yeah. I shared that photo the other day. Yeah.
Do you know if any of the direct point view CRTs that they fitted, like the flask?
The flask
if
ones.
Any of those have survived?
One.
One.
Who another collector, as I say, I've been in touch with the handful of people that own one of these, and one of the owners of the 359 has a flat CRT. Not in the set, it's up on the display on the shelf. The flat CRT was one that was made for the World's Fair. Well, it's hard to describe. Well, think about it this way. When you're looking at a picture tube, the electrons are hitting the back of it, and you're looking at this side. The light is being generated on the back side, and it has to work its way through the phosphor layer for you to see it. If you could get inside the vacuum and look at a picture tube from the inside, it's a lot brighter. So the flask CRT is like this big glass sphere. It sticks out of the top of the set so that you can see it from the other side.
It's a lot like a giant iconoscope.
Yes.
And the technology would later be basically recreated by Sony in the Watchmen.
Yeah,
That's how you view a Watchmen too. That's how they were able to get that tiny screen to actually have some brightness you could use.
Exactly,
So
yeah.
it's an interesting idea, but that had to be a nightmare to make. I cannot imagine making glass blown by hand.
That's why the speculation is very, very few of those flash CRTs were made.
I saw a set in Germany, in Berlin, at a museum there in 2022. I think 36. So wasn't Germany at the same time here? Wasn't Germany already like there with their
They were doing broadcasts,
Yeah,
and
yeah.
they were 180 line broadcasts. There were broadcasts, but they also funneled to a lot of hospitals, and they had viewing parlors set up because the Olympics were going on, and that they were trying to televise that and show everyone the superiority, you know. And they did some weird stuff with their cameras and their tubes. They had ones that had mechanical scanning in the vertical axis, but electronic and horizontal. They did weird stuff. And they had like intermediate film, which was like Baird's system, where film would be shot, developed at high speed, and then run through a camera like 60 seconds later. That's if there's any film from those Olympics, that's why there is, because it was an intermediate film camera. But what you had to do was basically boil the developer, so you're sitting over a vat of boiling very nasty chemicals. So those systems were just totally unworkable, and that's why, well, over in the UK, Baird lost within 6 months the competition.
So were American engineers looking to borrow anything the Germans had already figured out, like when this set was being made, do you think?
I don't think so.
I don't. They did have a license. The film scanner used a image dissector tool, so they used the Farnsworth image dissector as a film scanner. Because it's so light and sensitive, that's the perfect use for an image dissector, is to put it behind make telecine out of it, because you got as much light as you put through a projector. So they use that, and they did have their iconoscope clone, which weirdly apparently needed replaced every day, is what I'd seen written somewhere. But they had cameras all over, they did all kinds of stuff. And again, that was government funding, and much different than here, where it was all, you know, whether RCA did or did not steal some stuff, they spent close to what would be equivalent of $150 million getting television running in this country.
And what was filmed?
And that was just black and white.
And that was just black and white. Color, yeah, that was a whole other bit.
I know people love to dig into RCA, and I'm not saying that they were the greatest people on the planet, but they did put a tremendous amount of money and R&D into making television happen. They built the industry, yeah.
And they weren't saints, but they did a lot. And yeah, and color was a whole nother, because they didn't make a profit in the color until '64.
The chief engineer for that Olympics was Klaus Landsberg, who escaped after World War II to Los Angeles. He put up what was to be KTLA TV and made that a super independent station. That was actually the first super station before Ted Turner's. Channel 5 out in Los Angeles, and then they also were pioneers in covering the Tournament of Roses parade, RCA TK40 alpha color cameras. So there are scientists that did the Olympics, let's face it, eventually came over to the United States, and that's what helped RCA.
And one of them, who was at the Olympics, stayed in Germany, worked for Telefunken, and would later develop PAL.
Right.
And credited RCA a lot. Yeah. You know, all the people who make fun of NTSC, but you know, PAL was 10 years later. But.
Sure.
Did Philco have a prototype set at the same time as this, the CRT set?
Yeah.
Yes.
Yeah, others were tinkering as well. GE, I believe, did too.
And then Farnsworth out, because Farnsworth.
Oh yeah, back to the 20s even.
Yeah.
Zenith had a mirror inlet set too at the same time. It still exists.
Yeah.
In the 30s?
Yeah.
Okay.
And any of because you'll see, another big sponsor was, of course, Westinghouse, but they just bought RCA equipment and rebadged it Westinghouse. And they showed it at the fair at their pavilion, as well as all over Western Pennsylvania, Ohio, places like that. Which was, to be a person at a county fair in '39 to be televised, I think that would have been pretty.
Sure.
Where was this set before the museum got it?
They found it somewhere in Virginia. Something about ex-mayor of one of the towns had gotten it, and they modified it to a direct view. Had another cabinet sitting on top of it with direct view
Right.
CRT. So the original CRT was long gone when he got it.
Yep.
And then they went through and started putting it back together as best they could due to the limited information out there. It is
Yeah.
in the RCA service manuals, one of the red books. Because I looked it up, I had found a R6012, and Daryl over there was looking for one for his. And this one still had the original property tags from RCA on it. So Daryl now is the proud owner of that tube to go in his set that was missing. So there were a lot of, as you said, prototype tubes in there that, luckily that one, a 2x2 will work in a pinch.
Sure, sure. It'd be great if we could find the history of all these sets. Mine came out of Texas. How these sets survived, made it out of New York to various places around the country, I can only assume employees or engineers took them home.
Do you have any idea, Bob, what these would have been drawing wattage-wise when they run it?
Oh, I think it's on the service data,
300?
350. Yeah, it's not insignificant.
It was the CT100.
Yeah, I was going to say, it's not as bad as some later sets, because the tube count isn't that, well, most of these tubes don't draw that much power. And the B plus is only something like 200 volts. That doesn't, it's not a high-powered set, I would say.
If you're worried about the electric consumption, though, you probably shouldn't buy the tube.
No, no.
That's when utilities were cheap.
Plus, those are only probably, what, half an hour of programming a day or something like that. It's like you have it running off. I think that wraps it up.
Thank you.
Thanks.
Just in case.
Yeah.
You hold it in, you'll shut it off. One on the bottom.